Hello one and all, and welcome to Vetenskapsforum COVID-19 Sweden. My name is Jan Lötvall, and today we have a very interesting webinar together with Professor Bob Gallo. But first I will introduce Peter Horal, who is an associate professor and virologist, clinically working hard now to sequence different strains of SARS-CoV-2 virus from Gothenburg in Sweden. And then we have Professor Emeritus Anders Wallner, used to be at the Karolinska Institute, and has many years of experience with viruses. Anders is going to be our chairperson today. So I hand over the word to Anders.
Well, thank you very much, Jan. Just one correction. I'm still at the Karolinska Institute.
That's fine.
Anyway. It's my honor and pleasure to welcome an old friend, Professor Robert Charles Gallo, to this evening's webinar. And Bob, as we call him, is going to talk to us about SARS-CoV-2, but also about pandemics from HIV and on. Dr. Gallo, or Bob, is probably the best known medical scientist in the world. He got his medical degree all back in 1963 from Jefferson Medical College in Philadelphia. And after internship in Chicago, he went to the National Institute of Health, and particularly the National Cancer Institute. And after a few years, he became the head of the Laboratory of Tumor Cell Biology. And he stayed at NIH, NCI for 30 years. But in 1996, he went to Baltimore, where he was asked to come, and from the state of Maryland and from the city of Baltimore and the University of Maryland, and he founded then the Institute of Human Virology. And he is now the Homer and Martha Gudelsky Distinguished Professor in Medicine at University of Maryland and director of the Institute of Human Virology for the last 25 years. Now, Dr. Gallo is known for discovering the first human retrovirus, HTLV1, which causes leukemia, but not only leukemia, but also a neurological disease, particularly found then where HTLV1 is prevalent, and that is in Japan and the West Indies. And it's called tropical spastic paraparesis in the West Indies, and HAM in Japan. But you also see it in the endogenous population of Australia and wherever you have a lot of HTLV1. He developed a blood test so that, or a diagnostic test for HTLV1, so that it wasn't passed on by blood transfusions or by breastfeeding. So that was a very important discovery. Before that, he discovered the first cytokine, which is today called IL-2, which is an important cytokine to culture T cells. And he had to do that before he discovered HTLV1. But back in early 1980s, AIDS became an infection or a disease rather, and nobody knew what it was all about. And Dr. Gallo and Dr. Max Essex together thought that it must be a human retrovirus, and nobody believed them, of course. But he told everybody that they should look for human retroviruses, and he shared all the reagents that he had with everybody. And of course, the first one to isolate the virus was the people at the Pasteur Institute in Paris. But they couldn't show that it actually was the cause of AIDS. And in 1984, in 4 papers, Dr. Gallo proved that this new human retrovirus was the cause of AIDS, and he also showed how to make a diagnostic test, a blood test for this virus, and which has saved millions of people. So, and of course, Dr. Gallo has received numerous honorary doctorates, one from Karolinska Institute, but it's also amongst all types of scientific prizes. He's won the Lasker Award twice, in 1982 and 1986. And I think, Bob, you're the only one who's actually won it twice. Anyway, it's my honor and pleasure to.
Jimmy Brenner came, got a second one later. It used to be. It used to be.
Okay. Anyway,
get the GVN.
And yes, and also Bob in 2011 co-founded the Global Virus Network, and I'm proud to say that I was one of the co-signers of the original document in 2011 at the Italian embassy in Washington for the Karolinska Institute Center of Excellence in Virology. Anyway, the floor is yours, Bob. It's a great honor to have you here.
Well, thank you very, very much for very generous words. And also, it's a good opportunity to see Peter again and to meet Jan. So I appreciate you all being with me, and I thank you for this invitation, and thank everyone, the colleagues, for spending part of your evening with me. I really, people are cautious about saying they have any likes or dislikes related to Sweden for one reason or another. But I have to say, I always enjoy colleagues and friends there, and have amazingly great memories of past times that I'll store always. I hope you're not going to mind that I will not use any slides at all. Instead, I'd like to discuss ideas and concepts, hypotheses, and frankly, even opinions. Since he said I have the floor, that means I guess it's going to be my opinion. I'm going to try to search for general truths rather than this talk being sort of reductionistic. I'd like to speak as if we are in a dinner conversation seated together. Speaking of dinner, I know that the appetite of Swedish scientists is insatiable for medical science and data. So I asked Professor Anders to please schedule me right after you've had your dinner, when surely you'll have had enough food to eat, and I'll be freer. In fact, as we enter the topic of the COVID-19 pandemic, I think you're getting pounded daily by data and newspaper information. So I'm hoping that this kind of non-reductionist talk or perspective will be of some interest. And before jumping to the current COVID-19 pandemic, Anders kindly mentioned that I'm going to talk a little bit about generalities with pandemics that I want to share with you. Thoughts. Maybe that too will be of some interest. So the first thing I'd want to say is there's what's common about pandemics, at least what I think. And the first thing I think that is in common is that in the past about 150 years, since I think around 1889, as far as I know, all are caused by RNA viruses. The first is the flu of 1889, then the flu again of 1918, 1919, then polio of the early 50s, then HIV of the early 80s, and then SARS coronavirus number 2 of 2019. If you note, there's something else in common there. They're all separated by about a generation and a half. I don't know any meaning of that, but that is the case. There are also many epidemics in this period of time, and note that a great number of them, most of them, in fact, are also caused by RNA viruses like dengue, like chikungunya, like Zika, West Nile, Ebola, the first SARS, and MERS. Everybody's aware that we also have endemic problems with infectious diseases. Endemic problems are more apt to be due to a greater diversity of microbes, not just RNA viruses, but even things like bacterial disease, like tuberculosis, which pops up all the time, malaria, of course, a parasite, new things, relatively new, like Lyme disease, which I think is rickettsial, if my memory is right. I should have looked that up because I never did much I never did anything with Lyme disease and don't read much about it. What about another common factor? And I think another common factor is the origin of pandemics and epidemics. I think it can be said in one word: change. Change in a virus. Polio became neurotropic from an enterovirus and began to cause the disease, usually with only high virus concentrations, as I understand. What about the origin of the first flu, the Great Flu? I don't think we exactly know. It's somewhat controversial or debated, but it's certainly known where it was concentrated, and that was in barracks, Army barracks, World War I in Kansas, in the United States. And then World War I certainly helped make that a pandemic from epidemic. And then we can consider, well, I said polio, we said flu. We can consider ancient epidemics or that became almost pandemics. We can consider when Romans first visited the Eastern Mediterranean and people were exposed to new agents that they weren't exposed to before. Columbus coming to the New World and starting a pattern of coming to the Americas also was associated with epidemics going back and forth, and really maybe even you could call some of them pandemic. What about HIV? You know, since some of the people listening here, all of those that are looking at each other, almost all of them, I think, were present. And so we can't say 100% for sure, but I think that it's easy to speculate that it's the changes that occurred post World War II. Changes like tourism and travel, the economy giving rise to that, the airplanes, tourism, and the changes in mores and customs and habits, sexual promiscuity, the insanity of intravenous drug abuse, and lastly, medicine going from blood products, really, not medicine is not the right word, blood products going from one nation to another. I remember well that in February of 1984, we were testing serum for HIV antibodies from Japan. We had a young man with us who had worked with Abe at the hemophilia clinic in Japan at the time. And in February, there was no Japanese hemophiliac positive. We tested again in May of 1984, and they were 20% positive. They were using blood from Europe and the United States because by culture, the Japanese were not wanting to use, to give blood going from one Japanese to another. For some reason, it was culturally not accepted. So I think those are things that we can say that everyone is associated with change. If we jumped for the moment, I don't want to yet, but if we jumped for the moment to COVID-19, what would you do if you were trying to find the origin? I think I would look for whatever changed in the months preceding. If I was going over there for WHO, those would be the questions I would ask, or the year or two preceding. What is the biggest change? And I'll come back to that just in a moment when we hit the epidemic. A third commonality, I believe, of pandemics is us. We forget. I remember hearing Governor Cuomo of New York during the worst time of the whole pandemic for New York City and New York State. And he said, this is one we will never forget. I don't believe that. I believe we will forget, and it'll be a generation and a half from the last time we had an epidemic or pandemic. So if we cured this thing tomorrow, I will bet by 2050 or so, we would have forgotten. And I can tell you with HIV, I don't want to forget to say this, so I wrote a couple of notes down here. With HIV, we witnessed it. I came to the National Institutes of Health in 1965. I was actually on the wards first, where I didn't want to go. Leukemia wards of all places, I exactly didn't want to go. But I knew at that period of time, and for the years after, there was very significant respect for infectious disease. there was concern about it. There was a concern that infectious agents might cause cancer, for example, viruses. But by the mid 1970s, I can promise you, and you can provide evidence, this was gone. And arrogant statements were made, at least in my country, that you could not even begin to say today for political reasons, but they shouldn't have been made for scientific reasons. I'm talking about by some well-known scientists. We won't go there as to who, but it was said that, oh, that's a problem for those people that work in tropical disease centers, not where money should be spent in scientific research. And it's a problem for those people over there, not for us here. That was widely said in 1975, period. In 1974, I was at a meeting at Cold Spring Harbor, The Origins of Human Cancer. The conclusion of that meeting, organized by James Watson, friend, and also John Cairns. I don't say they necessarily made the conclusion, I forget, but it was part of the ending of the whole thing, that no cancer involved any infectious agent whatsoever. 6 years later, by the early 1980s, we had the most oncogenic virus, even though it's not widely spread, thankfully, HTLV1. Percent-wise, it's the highest oncogenic virus we know of. One of the highest oncogenic things, period. Far more than cigarette smoking. Then there was evidence accumulated for papillomavirus being causative. EBV was on the road hard because it's so common to prove that it wasn't, maybe a cofactor, but that's okay. That it's involved is clear in some human cancers. So let's just say involved. HBV, HCV, HHV8 or Kaposi sarcoma, herpes virus came into play, and then the bacteria Helicobacter pylorus. I can also tell you, my colleague David Zulla and I have, it's laboratory, kind of experimental laboratory and animal data, that a few other bacteria, 3 or 4, with mechanism may also be involved in human cancers by mechanisms that have to do with impairing the ability for DNA repair and impairing P53. So it wouldn't be an initiating event, but one that allows further development of abnormally growing cells to the point of developing a tumor and furthering its progression. But this is a subject of another day, another time, if we're all around to discuss such a thing, not here now. So my next point that I want to say, that although we have these 3 things I said that I think in common, there's still another, and that's public health, right? We all can all agree that if we want to take lessons from one pandemic to another, they're public health lessons. And some of my colleagues say to me, it's not original with me. And for example, our institute's board chair, who's a political actor, he's a Democratic operative, and he always says that and he follows this closely, and his offspring are in politics, that America allowed its public health system to decline substantially. He says it's stronger than that with 4-letter words, but I don't know if we can say that globally, but we experienced it in this pandemic. We really did let that happen, which really has to be corrected. So another factor in common is we can take lessons from one pandemic to another by virtue of what we need to do public health wise. But for me, it kind of ends there, because you try to take lessons from one virus to another. Sure, if they're cousins like SARS-1 and SARS-2 or MERS, you get some lessons out of it, scientific lessons. But don't take it too far, because a lot of things true for MERS and SARS-1 are not true for SARS-2. So you can go so far even when they're cousins, but how about when they're not cousins? What the heck does HIV have in common with SARS-2, these coronaviruses? Well, almost nothing. I mean, just think about it. If you are looking for lessons for one to go to another, scientifically with the virus, you have to take each one. You can't generalize. I don't think you can't find things that are much in common that it's going to be, epidemic or pandemic. I try to approach a new virus or a new disease in the following way. If I have the virus in hand and I don't know the disease it might cause, to get ideas, what do you start with? I think all virologists would probably do this. You start with tropism. What cells does it infect and what does it do to those cells? Rather easy with HIV because it's in HTLV1, their targets are really hyper CD4 T cells. I mean, it goes beyond that. We knew HIV infected macrophages as far back as 1985. It didn't get totally recognized for a long time, but it's really a CD4 T cell tropic virus, as everybody knows. So if you then say, what does it do to those cells? That'd be the next issue. HTLV1 promotes its growth, but HIV does not promote its growth. It promotes nothing or its death. So, and it also integrates. So that might suggest a latency, a period of time between symptomatology and exposure. And it would predict maybe immune abnormalities. It would predict maybe something close to AIDS. In fact, that was our thinking. We did think exactly that because of that approach. You could start with the disease. The converse is also true. You know, just think of it backwards, and you can go to think of what kind of virus you'd be looking for. You're looking for a retrovirus. Animal retroviruses and HTLV1, they infect T cells a lot. You hear the epidemiologists talk about blood and sex. Retroviruses mostly are transmitted that way. You know, there's a long latency from hearing clinicians talk about the disease, that long time before the disease shows up, but they were exposed earlier. Well, an integrating virus would do that. So one of the things on your list, once you accept the existence that human retroviruses exist, that it likely is a good bet or a reasonable bet. Now, this is when you're looking for a virus that's not readily obvious, like HIV and worse, HTLV1, which is extremely difficult to find, but not from a respiratory virus where often virus is practically dripping off your tongue, like SARS-2. I mean, that's not really, in my view, not really even discovering a virus. It's there, it's self-evident. So with that kind of background of general comments on pandemics, let's move into COVID-19 and the newest epidemic. What's the debate about where this virus originated from? I mean, for sure, we can say bats, right? I mean, if you hear Dr. Shi of China talk, and she gave a seminar at our institute not so long ago from this approach, Jesus, they've got coronaviruses present in bats all around China, all kinds of coronaviruses. And again, it's a point I'd like to come back to in a moment. So certainly this came from bats. But the next question is, did it come from her lab? Did it come from a lab? Was it deliberately made? I think the answer to that is no, not deliberately made. There's evidence, I think, pretty much against that. But no one can say it's not an escaped virus. You can argue against it. But actually, can we say any virus is not an escaped virus? I mean, you can say Ebola is an escaped virus in time. It came from bats. Does it have an intermediary? There's no evidence of an intermediary. I think the pangolin story is not on strong grounds. So we have to say bats to man so far. Is it in the market? There's no proof of that. There's suggestions, but there's data for and data against. I again would repeat what I said earlier. For me, I would start asking what changes occurred. I'd ask everybody, or maybe in the markets, around the markets, in the lab, or just in that whole province. What changes occurred last year, the year before, or the last months before that thing developed? Let's briefly go into pathogenesis. So everybody knows, I mean, my wife, who doesn't know anything of science, she's upstairs, she doesn't hear me saying this, so I can say it. She will tell you there's two phases. So I'm surely not telling anybody listening in here that there's two phases, right? We can divide it into the stage of virus entry and spread throughout the body, and the phase where you have inflammation. What about that early phase? Aren't you guys, everybody and gals, disappointed that we don't have better antiviral therapy for this by now? I am. I mean, maybe we're expecting too much, but HIV was historical. That was the first systemic serious disease for which medical science developed therapy that convinced the world that viruses could be treated like bacteria, but with more laser-like efficiency now that we had the molecular pathways of their replication cycle in front of us. So here we sit with this, and we don't have any, really any. good antiviral agent, except the coming monoclonals. But with the variants, I would ask, aren't you worried that they may escape the monoclonals? I am, but certainly I think the monoclonals should be applied. But I've been disappointed that in the whole world, we don't, what happened to protease inhibitors? I mean, people were developing them. Were they too toxic? Why not more polymerase inhibitors? What about inhibitors of the other, of nucleocapsid or assembly or things like that? Where are they? So I've been disappointed in the therapy, but also there's a group at Yale, a spin-off company called Nektar, that I had been involved a little bit in consulting only recently. It's their idea, it's their observation. They're observing that there's a it's an inverse correlation between the T cell count and doing well. I mean, you'd say, well, that's logical, but I did not know that you could divide early infection into 3 groups as they claim: those with no change in T cells at all, those with a slight reduction, and those with a very big drop. And the ones that have a big drop, you can predict are in serious trouble. So they're actually starting clinical trials very soon with interleukin-2. See what happens. So that's an approach beyond an antiviral approach. Now, what about the inflammation? Early in the pandemic, we were hearing from Italian colleagues and through the Global Virus Network, and I think Professor Valny, others may have been involved in some of those talks, that we were hearing that the interference with interleukin-6 was something that was productive, they were doing better with. And certainly they pushed hard dexamethasone. And I remember when the pandemic came to the United States, and I was saying, you know, the Italian colleagues in our institute were telling me they use dexamethasone a lot. I said, why don't they broadcast it more? They said, well, because we know it'll have to be done in an Anglo country before it's accepted. I said, oh God, no, please, you should be talking about it. It's not like that. And so they were beginning to talk about it more. But yes, dexamethasone does something. But I'll use this opportunity, bringing up the inflammation, to say what I said before the talk, that there's a tremendous advance been made by Yang Lu within our institute, the Institute of Virology. He's a Chinese-American scientist. He came from China. He was actually a farmer before he came, and he worked with the great Charles Janeway at Yale when he got involved as a postdoc in the so-called PAMPs, the PAMP, the DAMPs, and the pathways involved, and spent a good part of his career studying those inflammatory pathways, the steps and how they were triggered. And he got an interest not only in cancer immune therapy, but in graft versus host, excuse me. And in that pathway, his observations led him to a drug. Then along came COVID-19, and he saw that the inflammation was extremely similar to what he saw in graft versus host. He applied this drug. I'm going to tell you what it means, what it is, but I'll also tell you, I used to try to pin him down for what made you think of this? And I never got a clear answer. And the reason became obvious in time. I think it was a trial and error, and it goes back all the way to the time when he was with Janeway at Yale. And the molecule is CD24, and it's linked to FC for prolongation, I guess, of the life of the molecule. And the results we're hearing are startling. So I'm hearing from clinicians, I don't see the data yet, but the trial was stopped by the committee at the Warp Speed Committee in the US government. And they stopped it because the data were so dramatic. I mean, some of the data I heard from one clinician was if you gave remdesivir, it was marginal. If you gave dexamethasone, it's something. I've forgotten. Let's say 15, 20% were doing much, much better. But if you added CD24FC, they have a company name for it, I don't know what it is, that it was something like 95 to 98% out of the hospital, nobody dying, no side effects. So it's a tremendous boon. The bad news is we lost him. Merck gave him $426 million. He has to share it with his wife and one business person. But he's not the kind of guy, I mean, surely he cares because he's free to do anything now. So he bought a building and he bought a new house, and he had to leave our institute to get on with production of this compound, which I don't blame him. So he's already donated to the GVN. He's going to be donating, I know, to our institute. And he's a really good guy. But I just have to tell this story because it makes me feel good. Now, you're going to want to know all the data and everything else. So I weighed whether I said this or not this evening, because I've never said it before to anybody publicly. And I talked to Yang only today and said, Yang, I'm tired of waiting for when we're going to announce this. He says Merck is not letting it happen yet. They want to do every single patient they have to go through themselves. But if they gave $426 million, they did this already. So I'm tired of the delay. We have made no announcement from the Institute. They're writing the paper for the New England Journal of Medicine now. And I felt if I don't tell you, and it comes out in a week or two, I'll get a call from Anders or Peter saying, what the, whatever you want to put in there for the 4-letter word. You didn't say anything about this. So, but that's about as far as I can go. I just say, keep awake about it. And if you're in a risk group like me, you will want to be well aware of this. So let's jump to the topic of vaccine. And we'll be then heading into one last topic. We have to push the vaccine, obviously. But there does remain some questions. Durability is on my mind. Whether it will cover all variants is on everybody's mind. I suspect it will, but I'm far from sure, especially from the newest one. Global deployment is on the minds of everybody, I'm sure. Is this going to be so difficult? I mean, today's front page of the Washington Post was kind of the horror show that the rich are all getting it and the poor are getting nothing. So, and you have to recall that it took over a year, and I'm still not vaccinated at my age, nor my wife. It'll take a month after you get the vaccine for do any effect. Was there any possibility for earlier action, any earlier action that could have been useful? I would now like to turn to a discussion of which 1 year ago I barely knew existed, innate immunity. Now, Anders and I wish Peter too, and I wish all of you, Jan, would consider. I've had my second dose yesterday of MMR because I can't get OPV in the United States, but most people would believe OPV is the best. And you'll see what I'm coming to.
Maybe you should say what the MMR and OPV is.
Oh, I'm sorry. Yes, OPV is oral polio vaccine. I certainly soon will. And MMR is measles, mumps, rubella. And they are, what the hell do they have to do with COVID-19? Well, nothing and possibly everything. And I come to it in more detail. Not everything, but maybe something important. So why is innate immunity important for SARS coronavirus 2? Well, in a simple sentence, it's important for all respiratory virus infections and all infections. As I began to think about, well, first let me tell you what made me think about it. I had no knowledge at all about it. I'm ashamed, actually. I published, I think, a few papers in my career when I was in my probably about 28 or 29 on interferon alpha, how it blocked mouse leukemia virus replication, what its molecular mechanism was. I had no idea other things that interferon did. And I really didn't even think of innate immunity. I didn't even know there was an innate immunity, honestly. But what turned my attention to it started with the sequence studies published by the Chinese and the recognition that the spike protein that everybody was going to make the vaccine targeting spike was all going to be almost all the same. I said, boy, there's danger in everybody doing the same thing. But also, we noticed that the glycosylation pattern of the spike was very much like HIV, which is like Ebola, which is like flu. And what is that? Heavily glycosylated with side chains that are heavily mannose containing. So what? Well, our experience with HIV spike protein or envelope GP120, even bound to certain things like CD4 binding sites, which we do with the vaccine approach we have, we got some good data in primates. It was actually a bit exciting, but it was good data when we challenged in week 1, 2, 3, up to 10, let's say 8 to 10. And then we lost all protection. In short, there's no durability. And durability needs to be defined. To us in the Institute, and through lessons from Mark Slifka in Oregon, we kind of insist that there's a gamma phase of the antibody production, which means you got to be out for over a year or two. When you make 6 months, people are saying things are durable. That's not durability. Well, we started to think about this pattern of glycosylation may be what leads to the shortened durability of antibodies. And indeed, that's what we're finding. We got heavily funded to find out why, and it involves maturation of the B cells in their niche, not making proper plasma cells, not getting to the gamma phase of antibody production. That's a grant involving George Lewis and our institute, and Tony DeVico, myself, in collaboration with Warner Green and Gladstone Institute in San Francisco, and with Guido Silvestri, primate guy in Emory. But it's been mainly our work on GP120 that drives this. And so we now think we're getting close. And when by we, it's predominantly George Lewis, getting close to understanding the whys of it all, how of it all, but I'm not sure we can correct it at all. That's where we are in this story. But when I saw that glycosylation pattern, and my colleague George did as well, we began having these conversations again. I said, this thing is not going to likely last. So I still have that worry. And then I read about the seasonal coronaviruses. And you may be aware of the papers on the seasonal coronaviruses. The antibodies don't last. Less than 6 months, 4 to 5 months. It's just like HIV. So will this be the same? And if so, are we prepared for that and the variants? Those things became of concern. So that turned my attention to kind of other things. And then I went back to the sequence again and realized this thing has devoted a good part of its genetic information to avoiding innate immunity. Viruses don't like to give up genetic information readily, right? But then my collaborator at FDA, head of their vaccine development basic science area, Konstantin Chumakov, said, Bob, you're not so familiar with respiratory viruses. They all do this. And I said, that doesn't change anything, does it? It just makes it more important. It makes it all important for all respiratory viruses. Then I thought a little bit further about it. I said, when you reach maturity, let's say ripe maturity, how many respiratory virus infections have we had that we got better at before there could be any chance for adaptive immunity? That is to say, before you could have antibody, before you could have a specific T cell response, before, in short, you have any specific immunity. Don't we get rid of the vast majority in a few days? Do we really believe as virology people that it's because the virus got tired out or the virus didn't have any more cells to infect? I don't. It's innate immunity, in my judgment. That's the reason we get better. And then that got me reading about innate immunity and paying attention to papers. My God, 95% of all multicellular organisms have only innate immunity. I mean, it's only 5% of us that have also adaptive immunity. And then I read a little more. I read about bats. Bats, they all have coronaviruses. What do they control them with? They don't get sick. They're one of the longest living mammals, despite their high metabolic rate. How do they do this? Is it antibody? Is it specific T cells? No. The correlation is that they are expressing, I shouldn't say all, because it hasn't been done with all bats, been done with a few species, but they express constitutively a low to moderate amount of interferon type 1, always. Doesn't have to be induced. And they express or release a low but consistent level of activated NK cells, natural killers. Both, as you know, are key to innate immunity. And then, of course, the interferon becomes external, binds to its receptors, and induces other kinds of antiviral immunity, the likes of which I don't know. Maybe I'm sure somebody in the audience will know, but there are other antiviral mechanisms that we want to understand better. So those things really were what made me want to know more about this. And then I heard somebody say, but we know with specific immunity, with antibodies, et cetera, we get very sick if we don't have it. Look at severe combined immune deficiency disease. It's true. And that we have mice that also But those mice are alive when I look at them every day. And the boy that had severe combined immunodeficiency that I knew was the son of a director of the National Cancer Institute, he was also alive. I mean, he died of his disease, but he lived for a while too. Try living without innate immunity. I don't think there are lesions, there are mutations of innate immunity I'm reading about, but by gosh, if you have a serious mutations of innate immunity, I think those are lethal. So I believe we should be paying much more attention to this. So I want to jump and see what I have left that I want to make sure I say something about. We talked about the bats, finished with that. Clinical studies. So now we go to clinical studies. The most impressive paper that I have read was Bali Palandran at Stanford and his crew. They looked at all the genes expression and correlating with everybody they could see that was infected with their clinical course. And the correlation, I wouldn't be talking about it if it wasn't with innate immunity. I don't think that was their interest at all, but that's what they found. If your innate immune genes are turned on, you do well. If they're not turned on with significance, you die or you do poorly. Simple. Conversely, men with autoantibodies, seems to be males, have autoantibodies sometimes to interferon type 1, they die. They don't do well. And people with mutations in interferon genes don't do well. So it goes both ways. Early therapy with interferon, I don't know those results. Somebody told me there's good results with therapy, but I just throw it out to you. I don't know them. If there is, let me know about them. I appreciate it. Then on a GVN telephone call that we have periodically in the pandemic, earlier on, they were more frequent, about every week and a half, from people in different parts of the world, where we would get information from China, from Lin Fa Wang in Singapore. And so we could see really what was going on earlier than our government was realizing. We were in contact with Konstantin Chumakov. He's a Russian, came to America, became employed by FDA. As I mentioned his name already, vaccine, basic vaccine research part of FDA. And I became closer to him because of the following. He told a story that nobody paid any attention to, including myself, maybe 2 years earlier at one of the GVN meetings. This time I listened intently and tried to pick it up and push. Not everybody responded, but several did, including Anders here. He told the story of his mother and father. His father was a great Russian virologist, Chumakov. Actually, I think one of the greatest ever in Russia. But it was his mother who made the observation working with the father. And that was when they gave to adults the vaccine of oral polio from Albert Sabin. He was the guy who did the trials with Albert Sabin in Russia that showed that polio could be prevented by vaccinating with a live attenuated virus. When they gave it for polio reasons, they found out that it was also the flu season. And what did they do? They knocked off flu as well. That is, this vaccine gave better protection than the flu vaccines did. The year was in the 70s, 1970s. So this is now thought to be archaic, therefore it doesn't count, but it does count. And it was about the same time or earlier, similar results in Singapore. You read more, there are more such results. However, there's politics. There are people at WHO who believe they're going to eradicate polio. They predicted it for the year 2000 and predicted it every 4 years or so. And they want to hide or get rid of any available oral polio. Experts in this, like Eckhard Wimmer and like Vlad Egol in Russia, are extremely disturbed by this, because not only is it life-saving for people in developing nations, it's cheap, about 10 cents a pill or drop on your tongue, because it is easily deployed cold chain wise, because it's massively available, and because of a big observation in Africa with it, also with BCG, also with measles, mumps, rubella, all live, that mortality was rather dramatically reduced. Mihai Natea, in Radboud University in Holland, originating from Romania, in his presentation to a GVN meeting on innate immunity, said that the reduction in mortality in Africa was over 60%, that when he traced what it was from, what did you reduce? It was infectious disease, of course. And if you then looked at what infectious disease, it was predominantly pneumonias, lower respiratory tract infection. Jesus, this is important. So it's not going to be OPV, even though in America we used it from 1962, I think, to the year 2000 with no untoward effects. Because the serotype 2 of OPV, oral polio vaccine, can lead to polio. Sometimes. It's about 1 in a million doses. But in a vaccinated population, I quote Chumakov, billions and billions and billions of doses have yielded no polio. So we think it's a powerful tool. Gates is funding MMR. Gates people came to see us wanting to do OPV, but then realized that Gates would not approve that. Because he's using a type 2 that he developed, serotype 2 of OPV, that doesn't revert, and he wants to get approved for what they want for, namely polio, before giving it out to anything else. But we were proposing to use 1 in 3. I'm telling you all this because we tried to go forward in February. We got exciting enthusiasm from scientists, including review panels, but I was told at the highest level, it was not received well. So that's what happened to it. I then have been also thinking about, we're not done with that, and we are moving to MMR, but I've also been thinking about therapeutic use, which would be likely, at least in many parts of the world, tolerable. And as preventive, it would be tolerable and in a lot of the almost all developing nations. And Israel was using it until very recently, I know. What about therapy? Think about it. It's going to do nothing but possibly bad for the inflammatory stage. What about early? You're stimulating innate immunity. It's like having a chronic, modest level of interferon alpha. If you did this like my colleague at our institute, Dave Wilkins, got infected, he knew exactly when because he was tested because his son was infected and he was negative, and 3 days later he was positive. He ran to the drugstore and got measles, mumps, rubella vaccine. Now, I'm not going to quote an anecdote except to tell you he was not feeling well the day before and he felt well the day after. But there's every reason for us to be doing basic science on this, to do some contemporary research, to call on your colleagues who might be interested to think about that. We need publications in the modern era because people don't want to accept the publications of a long time ago. And there are people doing great things in it. And I mentioned Natea, he's one of them. And there is this, the Scandinavian lady, Christine Stable-Ben, who's doing clinical trials, who's done some of the important African work. So I've come to the end of the talk, and I want to give you my conclusions after this experience with the innate immune business, is that this is an extremely important, but underappreciated, understudied, and vastly undernourished field. My second is not really a conclusion, but more speculative. I believe if we had acted aggressively back in February, when we tried going forward, if we had succeeded in using these approaches globally, we might have well broken the back of this pandemic months ago. In organizing the future, I propose that we strongly consider having live attenuated virus vaccines or bacterial, but virus I think would be better, available and to exploit them. I think leadership going forward, we should question the role of government. Government didn't do so well, and we need them for funding. We need government also for oversight, for making sure no one's doing bad things. But do we need them as our scientists' leadership with a little crew of advisors only? What would happen if we used our last president as the government for the world? A pandemic means all. We have to do things for everybody. What would happen if we used the head of Japan or China or Sweden or England? I would say, get us private organizations. How about the GVN working in concert with WHO? You have to have an administrative thing, government support, government oversight, and some other private organizations like Gates and CEPI. That's what I think. Now, I close with one comment or two comments about the GVN. Its purpose is to help training young virologists for the future so that we're not left with chance. To have experts in every kind of virus throughout the world connected so that there can be available for not just advocacy or training of people, but for advice and planning. Funding has been a problem, but now we are for the first time in a reasonable position. From donations from board members and from a recent gift by my colleague that I mentioned to you, Yang Lu, of his $1 million, and he's not through. So we need, I think international scientists, I hope through the GVN, will come together and be far more assertive, aggressive, and talkative than we have been in this pandemic. I think we've been too laid back, quiet, and letting governments too much kind of run the show. That may be a dangerous maneuver, but I think it's a worthwhile one. I really thank you for, I probably caused you indigestion or whatever, but I hope it was worthwhile, some while anyway. Thank you. Thanks. I can't hear you, so that clap.
Yeah.
There you go.
Thank you, Bob. Yeah.
Yeah, that's better.
Yeah.
Thanks. Thanks very much. I mean, I know I took the whole time. So, or did I? No.
We can continue.
Not all the time.
No. We have. I mean, as long as you have time, we have time.
Well, I have time. I'm wide awake. Obviously, it's my time is early yet. I have a 3:30 interview, but I can be late. It's not important.
Hey.
One thing about antivirals, and I think, of course, one of the big differences between this new SARS-2 and MERS and SARS-1, of course, is that you have a lot of replication before you get symptoms, or you might not even get symptoms. And of course, once you get the symptoms, there is little virus replication. And if you then treat with the interferon, for instance, then probably you just add on to the symptoms and the clinical things. So you really should have the interferon before you get ill. And as for David Wilkins, did he have any symptoms when he got his?
He told me that at first he said he didn't have symptoms, but he ran and got the MMR. Then when he got the MMR, the next day he told me, "God, I feel better." So he must have had symptoms. I said, "Dave, you told me yesterday you were fine." He says, "Well, I was fatigued a bit." And he said, I had some unusual kind of fatigue. I said, "I see.
Yeah. That's
a symptom." So he had some symptom. So he's doing great. I mean, he's taking the MMR. He's going to take it again in another few weeks. I mean, he won't be eligible to get vaccinated in Maryland for still another month, probably. I mean, they're so slow. It's incredible.
Well, the same thing in Sweden. I mean,
okay.
And Sweden has done, I mean, Norway, Finland, and Denmark, our neighbors, have done very well, and Sweden has done extremely poorly. And we've had,
funny?
Yeah. And the reason being our public health authority, which really went for herd immunity back in the early, already in February. And they gave up testing and tracing already in February or late February, early March.
I really couldn't understand that on this. I remember early on, maybe in March, I had an interview with some San Diego TV thing, and they told me they were very happy that the day before, Dr. Atlas, who's a radiology guy.
I know.
And I never heard of him. I say he holds the globe on his shoulders. I know that. So Dr. Atlas, they were happy. He was he was advocating, and they were going to do it, sending all the children back to school. And it didn't matter. They're going to get herd immunity. So they said, "What do I think?" So I said, "Do those children have parents?" And he said, "Well, of course." And I said, "Do they have grandparents?" He looked at me. He said, "It's a TV guy." He said, "Well, yeah, sure." I said, "Well, you answered the question." I mean, the children go get infected. It's no big deal. We're going to get herd immunity. but they come home. They infect you and me. We're dead.
The thing they said in Sweden, the public health authority, was that children don't get infected, or if they get infected, they don't transmit. So, and of course they transmit. I mean, we knew, or I mean, and then for a while they said that that's so small that it won't reach up, because if you're 5 feet away, you can't get infected.
Well, don't feel bad. If I had a dime for every dumb statement that came out of our caravan, oh, I know I can't say what I was going to say. When just the caravan, I have a phrase for it. They come on every night at 5 o'clock for the last year until recently. My God, we have a lot of statements that were, most of them amounted to safe, like take 2 aspirin and go to bed early, the doctor's prescription. But I never got too much out of it.
In Sweden, they always say, wash your hands, and that's it, more or less.
Wash your hands. We get that too. Wash your hands. I get that all the time. But my colleagues, wash your hands.
Very good for the gastroenteritis virus. We don't have any calyx. We don't have any.
Wait a minute. I couldn't hear, Peter.
That works very well for other viruses, but not for COVID. To wash your hands. I think.
Yeah.
It's done wonders for the enteric infections. You don't see them, neither bacterial or viral. Well, we still have some Campylobacter because people still eat raw chicken, but otherwise, But I don't think washing hands has done that much for COVID.
No, it doesn't do anything, I think. But then again, I'm not advocating, dirty hands. It's
no, but just an observation.
But what we're saying is that face masks would be more efficient than for preventing COVID than only washing hands. Let's put it that way. Washing hands is fine.
In
Robert, are you
Maryland,
still there? You're
saying-
kind of frozen right now, but you're there, right?
well,
What?
Bob, you're still there?
your
Me?
picture is frozen. But
Yeah, your picture is frozen. I just want to follow up with the
No, I'm
question.
here. I'm sorry. I'm here just the same.
okay,
It's not
that's
frozen to me. I'm jumping around.
Good.
I
Anyway,
wonder why I'm frozen.
fine. You're frozen at a good angle.
Well, wait. Let me put stop and then go again. See what happens.
Yeah, that's
I
good.
think that's the best one of me. The previous. Am I
Um,
unfrozen?
yeah, you're dark now, but that's fine.
But we
Can
hear
I
you.
just ask a specific question, Bob? And that is, I've asked, I think, every virus expert that I know, how many examples are there of herd immunity through infection in a pandemic?
Gosh, I don't know. I really don't know.
Well, of course,
I would ask your colleagues here in Sweden. They will know.
well, of course, I mean, the Spanish flu ended up, and we didn't have any vaccine against flu at the time.
Yeah, it took
Yes.
3 years. It took 3 years before you had herd immunity and
Yeah,
killed
I
a
know.
lot of millions of people.
And a lot of people died. Yes.
Bob, may I ask you, a thought? It's now a lot of publications showing that antibody levels, both neutralizing and otherwise, the more severe disease you have, the more antibodies, both neutralizing and otherwise you see. In mild disease, the antibody response seems to be much lower and maybe not as long lasting. Do you believe here we can be dealing with the innate immune system, that actually those that do well and have a very rapid innate response don't get the systemic infection maybe, and don't develop as much of the
I've never thought of it, but it's a good thinking. I think it's an interesting idea. I've never thought of it before, but that is interesting. Yeah,
And
makes
if
sense. I have no proof for it, but it makes sense.
And the issue that you take up, first of all, thank you for this fabulous odyssey over pandemics, and also I agree completely with your memory. We would have lost the memory of COVID, or at least as what it was in a generation. Sometimes the loss of memory can be a blessing, but sometimes it can be a curse.
But
So,
look at HIV. I've heard people talking about this pandemic and listing other pandemics and not even listing HIV. Like HIV's being forgotten already. And we still have it. It's just interesting. No, yeah, it's a point. People could debate it. I don't really know for sure. Of course, this was an opinion.
also, one thing what is going to be very crucial is, of course, if what you say and think, if I understand it correctly, is that you don't really believe that the vaccines will be very long lasting. We might be having like the flu to come back once a year. But do you think that natural infection, because we made a study at our lab, you know, we've been doing PCR for respiratory viruses since 2013. And out of the 2,000 samples that had seasonal corona, we found 40 which had been positive more than once, you know, over this period. But only 6 of those had the same corona. And 5 of those were children severely ill of other reasons and under immunosuppression. And to me, at least, that shows that natural infection, coronavirus infection, probably gives you a decent and reasonably long-lasting immune response. It says nothing about the vaccines, of course.
How big
Well,
was
but there is a
percentage
study. There is a specific study on seasonal coronaviruses in which it's less than 6 months, 4 to 5.
From the Netherlands.
A thorough study.
Yeah, from the Netherlands.
I've
Yeah.
seen it also, but we don't. Strangely
But
don't
Peter, could you explain more exactly? So how many PCRs did you do, and how many
let me ask
infections
you,
did you see?
I'll have a quick look that I get the numbers right here, that I don't say something that I.
But if you think about it, the second wave, you know, maybe
Yeah,
2% are infected, bro.
In this was from 2013 to February 2020. All in all, we're 2,000 cases
Okay.
of seasonal corona. And of course, as soon as we had one, we started looking, did they, during this period, have any other coronavirus? And yes, indeed, we found 40 individuals who had during this period 2 corona. But out of these, only 6 had the same corona strain. And
Maybe those coronas don't come back.
And out of these 6, 5 were severely immunosuppressed children.
Peter, but how do you know the original coronavirus just didn't come back?
Yeah, that of course, that could be that, you know, the comeback every 5 years or something like that, or every 3 years, the same. So obviously, this is not a proof in no way, you know, that there is a long lasting. But what will eventually happen with this virus? Will it become like this seasonal children's disease, and then when we get it again as elderly, we will get it the light version? Well, what do you think, Bob?
Oh, yeah, Peter, like you guys, I get that question, those kind of questions, and generally speaking, my best answer is I don't know. I mean, you can say, what do you think? What do you guess? Is a better term for it. What do I guess? I would guess, get on top of it, and probably, I think the antibodies will wane. But I'll send you I'll dig out, if I can dig out, I'll send you that paper.
Do you think we can?
If the antibodies wane, you know, or if the mutant, I worry about some of the mutants. I mean, if they escape, Jesus.
Yeah. Do you think the multivalent vaccine could help long term? So something that beats all coronaviruses?
That would be nice. Sure. That's a good good thing to think about. And I think again, though, if I saw a new respiratory virus, maybe it doesn't have to be respiratory, but a respiratory virus, let's say, again, come brand new and and we don't have anything, I would really be much more aggressive in arguing that, for Christ's sake, use a safe innate immune stimulator until you get a specific vaccine. Okay. Even then, you know, is it really, you know, someone said to me, you know, but of course, if you have a specific vaccine, it's better. And I asked the question, but why is it better to only work against one thing if you could work against 10? The only thing better about specific is durability. That's what's better, right? Is there any other advantage? One is take OPV or MMR, cheap, easily available, can bring them to the developing nation. The problem is lack of durability. Are they as effective? That's another question too. Yeah. But if you demonstrate they're equally effective, what would be reluctance in using them immediately?
So I heard that Cuba was immunizing more or less the whole population with outer membrane vesicles from bacteria, exactly for the purpose that you mentioned, to induce innate immunity. I didn't follow the details of the pandemic in Cuba. They did that in the summer and early fall. I don't know how that has evolved over there.
I think Andrew's good friend, or our friend, Billy Hall, has said something like that in a note to me recently as well.
I think they gave up on Cuba.
Oh, all right.
Yeah. Anyway, so
Bob, I did take the NPR on your advice, but thinking about the innate, is it a good idea to have multiple, like we do the NPR, to have multiple? It obviously works. Seems that we know that it works, the NPR, but how is it to vaccinate at the same or in close proximity with two different live vaccines? Is that actually a good idea? Because we have the.
I don't know about the two different ones. I don't think there's anything wrong with that. And everybody that I've spoken to and thinking about it is the data of Mihai Netea, again, this guy in Holland, is that if you get boosted again, it only makes things better. He's got some aspect of the mechanism of it. I don't know if you know it. They did trained innate immunity. He's the one really doing, I think, the most important work on trained innate immunity, at least that I am aware of.
Is there any randomized trial going on for testing those innate immunity activators to prevent COVID?
Yes, there are a number of them being done by this woman in Denmark at the University of Southern Denmark, Christine Stable-Ben, B-E-N-N. She's involved in some. Netea himself, Mihai Netea, the guy in Holland, is involved in some. We were unable to get going with OPV, but we have, it's not us that has, but we have close contacts with a trial being done in India. If those are positive, that will make noise. If those are clear-cut positive, it'll make noise.
We tried with the live influenza and AstraZeneca, but that didn't work out either.
Well, yeah, the AstraZeneca with the intranasal vaccine is live. We talked to them. We were able to get to, you helped us get to the right people, and we just told them about it, and they were helpful in advising ways we could go. We didn't go those ways, just lack of funding, etc. We would need data mainly from them. I don't think they're ready to get deeply involved in that. They have their own fish to fry right now, right?
Yeah.
They have a pathway, and companies don't like to change on a pathway.
Do you have any suggestion which parts of the innate immunity are important? Which TLRs do you think are important? If it's interferon responsive elements that are important, and or so on.
Yeah, because that let's just take the lesson from SARS-2 genome. It's targeting TLR3 and 7. It's trying to incapacitate their ability to respond.
Because AstraZeneca had a TLR7 activator, I believe, in the pipeline to try to prevent asthma or something like that.
I would take it. I mean, if it's not harmful drug, I would take it. Asthma. I think that's rational from what we see. I mean, that's what the virus is trying to knock out. 3 and 7. That's with some specificity. So that's telling you that must be important, right?
Yeah.
I guess. But go back to the trained innate immunity. What Netea says is that it's a acetylation methylation thing. That when you, as you know, the histone repression, then you acetylate, it allows it to express, so the DNA is open. And he said what's happening is that it's not completely deacetylated and demethylated. And he said, think of it like a book that you're reading, and then you leave a bookmark. So the next time you open quicker and more definitively. And his statement is taking more than one and getting boosted again and again is only good, not bad. You do better and better. The innate response will be deeper and longer lasting. So, and it would only be good for the specific vaccine. So you're not harming the specific vaccine. The problem is if you tell the trial person that you did that within 2 weeks, they don't want to give you the vaccine because they want their data clean. Right?
I'm off for my third MMR shot next week, I can tell you.
Well, you're ahead of me by about 2 to 3 weeks, as ever.
Anyway,
I'm not a skeptic, but I'm curious.
How often should we take it? It seems Bob, you say.
That's another good question. With BCG, it seems to last longer. He says it goes out to 6 months. He's measured.
That's not a nice vaccine. That's not.
No, I know. We don't want to even think about it. He wants to go to OPV himself. I mean, that's what he wants to study now. I would say, well, I'll say what he says. He guesses, Chumakov guesses 2 months. max.
Also,
And-
yellow fever, it's not that, they have the problem also if you then actually happen to get yellow fever. Some people have an antibody enhancement, So I don't know if probably today, and we, of course, in Sweden, we don't have the oral polio vaccine. We have the chicken pox. We have that is given to children. Not the one for
shingles, live
Not the
shingles is
shingles,
fine.
not the shingles vaccine. That's not live. But the one for children for
No. Shingles is live. There's a live and a dead one. Merck produces the dead one.
Yeah.
And it's a painful one. So there's live. I took live once upon a time.
I did too.
Live
Yeah.
one is given to children.
Look, the choices we have available to us are live shingles, the intranasal mist for influenza, MMR. That's about it. I mean,
So I have one question
from the audience.
Yeah, we have some questions from the audience, but before we go there, I just have one question regarding innate immunity activation, as you suggest, and whether it increases the effect on memory immunity in an infection or vaccine. Could it help the vaccine, or would it attenuate the effect of a vaccine?
no, the evidence, yeah, well, I wondered the same thing. I had no idea.
Yeah.
But
Yeah.
when I talked to Chumakov, when I talked to Natea, who've been around this field for a while, said, no, it'll just make it better. You always get innate immunity before you get why are they using adjuvants? This is just a better adjuvant and longer lasting. Yeah, it says, so it'll do nothing. The adaptive immunity evolves out of innate immunity, right?
Oh, yeah.
It came out of it. So
You
they
want to-
think if it has to make it work better, not worse.
You want to take the audience questions, Anders?
I just take one I saw, and that is about the Great Barrington Declaration.
What?
The Great Barrington Declaration. Did you hear about that?
Not in the least.
No,
No.
it's a declaration. We have one of it was a declaration signed in a place called Great Barrington in the U.S. and Connecticut, I think.
No.
I'm from Connecticut, so don't curse.
Yeah, I know.
What
It was
is
about
the declaration? What is it?
it was about herd immunity and going for herd immunity rather than lockdowns and so forth. But if you haven't heard about it,
No.
No.
If I were very, very young, and if the whole world, if we all died at age 15, I'd be for it. But I don't think it's fair to adults. Anybody over 40, 50 is going to get in
and
trouble.
also children could get very sick. So
They
I
can.
mean, it's
Yeah, I mean, you're playing with fire. I mean, I don't know this. I don't know. I know people in Connecticut who are involved in the state policies, and they certainly would not agree with that. So I don't know how that came to be, but
I have another question, if I may.
sure.
Move on to another. So you said there was not any real connection between HIV and coronavirus. Well, I heard the hypothesis that maybe immunosuppressed people have a greater chance of having virus mutate inside of them and spread new versions of the virus. And potentially the South African mutant could depend on relatively immunosuppressed HIV infected individuals in South Africa. Do you have a
In a virus, I think, I mean, let's just,
because they have
I'm not sure this
infection
is
longer, they
common
have more
sense or
virus
not.
growing, right?
no, I understand it. I understand
Yeah.
the question perfectly, but let's think about it together. Because I mean, I've not thought about it before, but think about it together. If a virus is spreading naturally, infecting a million people, millions of people, doesn't it have enough chance to make every possible recombinant deletion and mutation from unfaithful copying, as if a person allows more replication in a rare individual or an unusual individual? Yeah, there'll be more virus replication. There'll be lack of immune response, but so much viral replication going on worldwide, I don't think that something necessarily novel is going to come up in an immune suppressed person. So for me, I wouldn't worry about that too much. I mean, I don't.
It's the same. It's very much the same. The South African and the Brazil mutation. So one wonders, did it develop at both places, or was it transmitted from one place to the other?
No, I
And
think
if
these are independent.
Yeah, and then they will develop. They will come up everywhere. There's lots of virus infection, I suppose.
Are you going to argue because Brazil and South Africa have a lot of HIV?
Yeah, that too, of course. But otherwise, I mean, in Brazil they have a lot of virus, and I suppose this. I mean, America, the U.S. With the 25 million cases, and you probably will get that mutant spontaneously there as well.
And there's said to be one mutant in Los Angeles County that explains the the growth of the virus in Los Angeles. I'm not sure you've heard of that, guys, but
No.
yes. So I don't.
You know, people reach those conclusions a little bit rapidly. You know, you do need significant results.
I think this was
before you make that
people from
comparison.
Cedars-Sinai. They were serious people. So
I see.
yeah, sequencer. There are some questions from. We are also broadcasting this through Facebook, and we have Lennart Engström here asking whether there's any use for interleukin-6 inhibitor, interleukin-17 inhibitor, or interleukin-23 blockers in the treatment of acute COVID-19.
I would say yes. I don't know about 23 so much because I don't know much about 23.
Mm-hmm.
You know, I learned to stop counting after 20. It's just getting a little much. No, but yes, I think the targeting interleukin-6 has been done with positive results, and 17 would make sense. Yes.
And there's another question regarding the vaccines. We in principle we have the Moderna, we have the Pfizer, and we have the AstraZeneca. And the question from Anne-Marie Eriksson here is whether they are safe.
What you know, they're.
I guess we should balance efficacy and safety.
Of course. They're not perfect. I mean, there are over 30 cases we know about in the United States of anaphylaxis, right? 30 cases is not none. It's something. But you know, the amount of people vaccinated is now pretty large. So yes, it can be not safe. You can get anaphylaxis if you're allergic to something. They think in the case of Moderna, it might be the oil that it's in. So, I mean, this is a problem with anything you inject in yourself, right? Mm-hmm. So, but it's rare. We can say it's rare, but it's more common than I thought. I thought there were a few cases of anaphylaxis, but yesterday I was talking to some people at NIH to keep track of this. They said it's over 30. No, I said, oh, it's not so small, but it's still very unusual.
Yeah, and Charlotta Bond is asking, how about bacterial vaccines, pneumonia vaccine, or meningitis vaccine, perhaps?
You mean for live attenuated?
For activating the innate immunity. No, we have a pneumonia vaccine here. It's not live, I don't think, right?
They have to be live. If they're live, the answer is yes. But I don't know that there's no a priori reason I could think of to say that that it must be a virus that's live attenuated. BCG also has effect. So any live bacterial vaccine in theory could be as effective. However, when you think about it, there's a lot of data. If we could only use OPV, there's a lot of data with OPV from old days. And it's a safe vaccine and cheap and it's available. I mean, you know, 2 drops on your tongue and you're done. So you can go around with a pill in your pocket or a little dropper in your pocket and take it when you want it. If I was at the beginning,
through the wastewater, do you also vaccinate everybody around you? Not everybody has to take it. You know, people get immunized without even knowing it. If you have the oral polio vaccine,
right? Well, once again, though, in a vaccinated population, if you are vaccinated against polio, there's not one complication been reported with OPV. No, but to answer the question, in fairness to the woman who was asked the question, there's no reason not to be bacteria until proven otherwise. And since BCG has some effects, maybe one of these bacterial, if they're live, would be as or more effective. We don't have a reason to say.
We have a lot of questions coming from Facebook now. Gun von Krusenstjerna is asking whether you are infected, but not symptomatic, and then you get the vaccine during that infection, could that mess with the immune system? Is that helpful or detrimental?
I can't think of how it would be harmful, detrimental. Whether it's helpful or not is toss of a coin, because even pardon me while I wipe my SARS-2 away. I would suspect that if it had any innate immune induction, it would be helpful to still have it if it was very early in infection, very early. But I don't think the messenger RNAs carry much in the way of innate immune stimulation. I mean, just an RNA that gets translated.
There are two questions coming that are related from Facebook as well, and that is whether you think this is an aerosol infectious virus, and whether facial masking will help and protect.
Yes and yes.
Okay, that was clear, guys.
Yeah. I mean, there's I think. Oh, look, our 5 o'clock committee that used to come in every night with Trump were very dogmatic about it not being transmitted by aerosol. And in China, they already had experience and came to a conclusion it was. But they wanted to see, double-blind studies, proof. I mean, come on, give me a break. With 5 anecdotal cases, you could say aerosol transmission. You don't need all this kind of so-called science that you're going to prove it's transmitted. It becomes obvious. So there are many descriptions of this. There's like a taxi cab story in Italy where a guy was infected. He's in the cab with people. Nobody got infected, but he continued on a long journey and other people joined that car. And instead of 15 minutes, it was more like 3 hours. Everybody got infected.
Isn't this, in fact, part of the reason for the seasonality, that in wintertime we have very low humidity, especially indoors, and that even a droplet immediately dries out and becomes an aerosol? That's why
I think so.
The infections in the wintertime. I don't know.
That's what
And in terms of masks, the governor in Maryland is now asking for double masking. There are 2 masks.
Austria.
Oh.
I'll be honest, I use 2 masks as well when we go to the shops, and we enter the shops for like 10 minutes, 15 minutes.
And I'll be even more honest. I don't go to the shops.
Yeah.
We use something called Fresh Direct. I order it and it's delivered to the house.
Do you think the infection can be transmitted by food? I don't think so, but it's been discussed.
The answer is I don't know, but I'm with you. I don't think so. It doesn't make sense that it's going to be transmitted easily by food, or not easily, not transmitted by food. I don't think so. No. I have to admit, it's become a habit of me when I take the newspaper in the morning, that the cover of the newspaper, which is plastic, when I take it off and throw it away, I immediately then wash my hands. And I wonder why I don't have any problem with the newspaper itself. But it doesn't make much sense in a way. But in other words, I'm afraid of the guy who's delivering the paper rather than the guy who's put the paper together. And I have no reason to believe that. But it's easy to do. So that's when I wash my hands in the morning after I get the newspaper and take off the plastic. So
we have some additional questions here, and a few of them come down to one thing, and that is, what is the advice to the world to stop this pandemic? If I would like to ask you, Robert, and I'd love to have Tony Fauci on the channel as well, ask him the same question. What should the world do to collaborate to stop this pandemic at this stage?
Yeah, well, Tony's not going to tell you about the world collaborating, and that's going to be a different story. Yeah, and he's not going to talk so much of the science of it. So I would say I ended the talk with what I think. The Global Virus Network and things like it need to group together and be more aggressive. We need to work together as scientists. Getting more specific, I made the comment that I think we should exploit intelligently the use of these innate immune stimulators. Other than that, we've got to hope like hell and do everything possible that the current vaccines are working, that people are taking them, and that we guard ourselves against these variants. If the variants occur, it is the obligation of the people making the vaccines to have them tested in animal and not just in culture to see if they're still protective. And if they're not, to get immediately working on covering that variant with vaccine. If they're going to stay with the spike, then the spike of the variant.
Will the mRNA vaccines have to be tested fully from the beginning, like the first version, or could they be deployed quicker after safety?
I would think
phase
that
A?
after safety, they should be deployed immediately. Yes. Right. I see no reason that they have to go through everything again. No, I think even the safety would be relatively short term. I can't believe that a minor variation in the spike is going to change safety of the vaccine per se. So those are things. And then, yes, I think we have to be forceful about the masks. I hate them. I mean, I don't like them as much as a lot of people, but I don't think we have a choice. You have to wear the mask, and we have to be cautious as can be. I don't believe in the concept of herd immunity. Yeah, does it ever occur? Of course it occurs, but I'm not convinced if everybody's having antibodies that we're all going to be protected anyway. I don't know that. And getting naturally infected, does it protect you from reinfection? I guess the data suggests so far that it's consistent with being protected because very few reinfections have occurred, right? Small number. So it looks like that's reasonable, but it's too dangerous. So doing what we're doing now, but with more vigor, patience, and making sure the damn vaccines are taken and that we watch the variants. And if they're not durable, we have to put our thinking caps on.
Any last questions and take-home messages from our panels? Start with Peter.
All right.
Or start with Anders, maybe.
Yes, I'm mute. No, I think it's been, thank you again, Bob. It's really enlightening. And, these pandemics, they're going to be with us. The big question is which will be the next virus? And you're not allowed to say influenza, but, we can think about it, what's going to be next. And we sort of almost forgot about pandemics because we said before in a century, you have 3 pandemics, but then there was so long, really, unless you count the swine and of course HIV, but that was not really pandemic in the classic sense. We sort of forgot and thought that, pandemics were nothing to worry about. And now, and the question which is going to be the next one, and how are we going to be?
It'll be X.
We prepare for it.
And I would say that I agree with Bob. I think that all countries should stock with oral polio vaccine, and the minute you hear of a new possible pandemic, everybody should take it.
Look, for me, I thought the Army would jump on it, because if I'm running a group of soldiers and they have to go into foreign places all the time, why not have it as part of their gear? You know that a new epidemic appeared in a region, and you have to go to that region, pop the pill, and that could be, MMR you have to inject, OPV, bingo, it's just a little pill. But there's a problem with some WHO people regarding this. That this is a headache. There may be others. There may be others that would be totally acceptable that we got to think about. I don't know about things like rotaviruses, echoviruses, where you may be able to do something with things like that that are innocuous viruses, or maybe even the seasonal corona. We have to think this way now a bit, and it has to be something novel. Yeah. By the way, I also was enlightened by you guys.
Thank you. I mean, before we end and before Anders finalize this meeting, I want to ask all the audience to please become members of Vetenskapsforum COVID-19, vetcov19.se. We really appreciate your participation in the community. And I ask Anders to please summarize and thank Bob.
Well, thank you very much, Bob. It's always a pleasure to hear you, and it's fun seeing you again, although I can't see you right now.
Same for me. I hope we'll be together before another year goes by. I hope so.
Okay, and I hope that this will be over soon, so that this summer we can start traveling again and
Great.
have
Great.
meetings in the late summer.
Great. So, that's
Oh.
just on time. That's going to be
Okay.
the guy from.
That's a good signal. Thank you, everyone.
Thanks a lot.
Okay, I
Bye
better
now.
take it.
Thank you. Bye.
Bye bye.